Hello viewers, welcome to my channel. Today in this video I am discussing most important topic that is uniform continuity. This is the one of the most important topic in the real analysis. Uh, Uniform continuity questions usually asked in Kset and CSIR and many other entrance examinations also. In this video I am discussing definition of uniform continuity and examples of uniform continuity and some important results and tricks to solve the uniform continuity. Okay, I am already one video uploaded on uniform continuity. I solved Kset examination problem. Okay, let's start our session. What is uniform continuity? Definition of uniform continuity is let f be a real valued function defined on a set D subset of R, then f is uniformly continuous on D where D is a domain. Okay, for each epsilon is greater than 0, for all delta is greater than 0, such that x1 and x2 belongs to D and mod of x1 minus x2 is less than delta. That implies mod of x1 minus f of x2 is less than epsilon. Here we have to notice one point. Delta depends on only an epsilon, not on points. Now we have to discuss what is the difference between uniform continuity and normal continuity. Continuity means we have to check the continuity at that point. Okay, we have to check the at that point, but in uniform continuity we discussing at interval. Okay, uniform continuity we checking uniform continuity at interval, and that is not at points. Okay, this is the difference between uniform continuity and continuity. Continuity is local, okay, local point. Uniform continuity is global point. Okay, now we have to take one example to clear this definition. Suppose I am taking one example. If the function f of x is x square for all x belongs to real R, this is the domain for all x belongs to R. Okay, by using definition of uniform continuity we take suppose your x and y belongs to real R, then by using this definition mod of x minus y is less than del. Okay, that implies mod of f of x minus f of y is less than is equal to what is f of x square and minus y square. This equal to this written as mod of x by using a square minus b square formula, x minus y and x plus y, and this equal to mod of by using now we have to return this as by using mod properties of mod, that is if suppose that mod of xy is less than or equal to mod x and mod y. By using modulus properties we return this as less than or equal to mod of x minus y and mod of x plus y. We know that what is mod of x minus y is less than del, that means less than del into mod of x plus y. This entire term is written as we taken as epsilon. Okay, now we have to find what is the del what is the value of del mod of x plus y is equal to epsilon. We taken this entire function as epsilon. Okay, then del is equal to epsilon by mod of x by y. Now the del is depend on points, not on epsilon. Okay, here depends on epsilon as well as points. This is not uniformly continuous. Here del is depends on epsilon as well as points, so that's why this is not uniformly continuous. Okay, on this domain, that is for all x belongs to R. This written as like this also, that is open interval minus infinity, also infinity, minus infinity comma infinity. By using extended real number system we have to tell this as not uniform continuous also. This is another method. Okay, and we change the domain. If suppose we take the domain as for all x belongs to closure 0 to 5. Okay, closure 0 to 5, then the domain is changed if take x is equal to 5 and y is equal to 5. Okay, then x is 5 and y is 5, we take 5 plus 5. Okay, what is 5 plus 5? 10. Okay, the all the values less than 10 only, then this taken as a epsilon by 10. Del is equal to epsilon by 10. Here 10 is constant. Here epsilon depends on only epsilon. Sorry, del is only depends on epsilon, not this point, because this is constant. That's why del is depends on epsilon. Therefore, we say this as uniformly continuous. Now we have to observe one point. If domain is changed, then uniform continuous also change. Okay, if domain is changed, then uniform continuous also change. We have to remember this point. Okay, now we move on to some important tricks and results. Okay, I hope you understand this example. Next we move on to important results and tricks. That is important results by using graphs. By using graphs also we have to check the uniform continuity. The first point is the graph of f of x is parallel to y-axis, never uniform continuous. Okay, suppose this is already we checked for all in domain R, this function is not uniformly continuous. We take the graph, see this is the graph of x square, yes or no? Okay, this is parallel to y-axis, this line is parallel to y-axis, then we say that this is not uniformly continuous. Suppose we restrict this domain, suppose we take this domain as like this, then we say that this is uniformly continuous. This is not parallel to y-axis. Okay, when we restrict the domain, we say that this is uniformly continuous. This is parallel in domain R, this is not uniformly continuous. This is not uniformly continuous. Then second point is, if graph of f of x parallel to x-axis is always uniformly continuous. Suppose we take sin x. Okay, the function f of x is equal to sin x or cos x. Okay, sin x graph is like this, yes or no? This is parallel to y-axis, so then we say that this is uniformly continuous. Okay, and we take another example, y is equal to x by a straight line. We see this is not parallel to y-axis, this is also uniformly continuous. And we take graph of cos x also. This is the graph of cos x, this is also uniformly continuous on particular domain only. Okay, on particular domain. Okay, then another point is, if f of x is continuous on open a comma b and limit exists finitely at both ends, then f of x is uniformly continuous on open a comma b. Okay, then that is limit extends to a f of x and limit extends to b f of x. Then what is the meaning of this point is, if suppose the given interval is open interval, then we check it. Suppose the given function is continuous on that open interval, then we only check at endpoints. Okay, we check at endpoints. If the both the endpoints are exist finitely, then we say that function is uniformly continuous. Yes or no? We remember this point. This is most important point. Okay, and we take another point. The fourth point is, if f of x is continuous in closed a comma b, then we have to observe one main important point, that is the necessary condition for uniform continuous is the function is continuous, then only that is the continuous is the necessary condition for uniform continuity. Okay, if the given function is continuous, then we move on to check the uniform continuous. Okay, if the given function is not continuous, then we directly say that the function is not uniformly continuous. Okay, remember this point also. If f of x is continuous in closed a comma b, then f of x is uniformly continuous on closed a comma b. This is important point. we have to remember the sufficient condition for uniform continuous is if f of x is continuous in closed a comma infinity and limit extends to infinity, f of x is exist, then f of x is uniformly continuous on closed a comma b. This is only sufficient condition, this is not a necessary condition, this is a sufficient condition, this is not necessary condition. If this condition is false, then we say uniformly continuous. If this condition is not false, we can't say anything. Okay, we can't say anything. We move on to a normal method. We check the by using normal method. Sin x. Suppose we take one example. By using example for fifth point. I give the fifth point. For fifth point, I give the example. Suppose we take f of x is equal to sin x. We take domain as 0 to infinity. Okay, by according to this point, we check that limit extends to infinity, f of x is exist, that is limit extends to infinity, sin x is okay, this is bounded between this is oscillate between -1 and 1, is this is not exist, that means we can't say anything, this is uniformly continuous or not. Okay, this is only sufficient condition. Okay, this is not necessary condition, necessary condition is continuous. Okay, this is by using definition of uniform continuity, we prove that this is uniformly continuous on this interval. Okay, in this control. Otherwise, I give another trick also to check how to check uniform continuity. If the given function is satisfies a lipstick function, okay, that then we say that the given function is uniform continuous. If the given function is if the given function is differentiable, okay, if the given function is differentiable, then a Lipschitz function is satisfies. Then if Lipschitz function is satisfies, then we say that the given function is uniformly continuous. Okay, the differentiation of sin x is cos x, this satisfies the condition of Lipschitz condition, then we say that this is uniformly continuous. Okay, this is also another method to show that the given function is uniformly continuous or not uniformly continuous. Okay, like this we solve the problems. Okay, I am already uploaded one of the video on problem asked in Kset examination. Please watch that video also. I'm that video link I am given in the description. If you like this video, please like, share and subscribe my channel for more videos on mathematics, the CSIR NET, Kset and many other MSc entrance also on higher mathematics. Thanks for watching. Thank you.